What if I told you a planet-killing asteroid could be hurtling toward Earth right now? Hello everyone, this is the Space Cafe podcast, and I'm Marcus. That's right, the next extinction level event could happen not in our lifetime, but, well, sometime in the future. A Chicxulub type asteroid, the kind that ended 200 million years of dinosaur dominance, might already be on its way. We do not know when or if Chicxulub 2 might strike, but the threat is real. Luckily, we have what the dinosaurs didn't, planetary defense strategies, at least in development. Today we're diving into the fascinating and urgent world of near-Earth asteroids and planetary defense. Joining us is Dr. Dora Föhring, planetary defense scientist at the European Space Agency, ESA, and an adventurer at the forefront of tracking these celestial threats. Dr. Föhring was part of the international team that successfully altered an asteroid's orbit for the first time in human history. She'll share her experiences from observing elusive asteroids to participating in humanity's first asteroid deflection mission, DART. Are we ready to defend Earth from a cosmic impact? Well, let's try to find out.
I remember when I was an undergraduate, we had to do labs, astronomy labs, and we had a bunch of different projects that we could choose from. And most of them were fairly straightforward, globular clusters, things like that. And I remember there was this one project on near-Earth asteroids, and the instructor was saying, "Oh, this one's really challenging." And I was like, "That's what we should do." And I think what first drew me to trying to observe near-Earth asteroids is exactly that it's technically a very challenging thing to do, because many times if you're just observing, don't want to diss anyone's work, of course, but many times you're just observing, taking pictures of the sky. You're looking at stationary things, and you can try to get your perfect adaptive optics, your perfect multi-slit spectrograph on there, and you just sit on the object. So I did some spectroscopy during my time, and you're just sitting there. So I find the really exciting thing about NEOs is that they're there when you have the chance. You have to get them, because you might not get a chance the day after. I was doing my PhD in the UK, so it was very cloudy. You took whatever chance you got. That was like my initial introduction to NEO. And then afterwards, I got a chance to observe NEOs when I was on La Palma, even though that was not the main focus of my PhD. But so as a student support astronomer, we would often get kind of requests or directors' requests of, okay, here are some targets on this night that you can observe. And many times people requested things that were like, oh, it has to be perfect photometric night, perfect seeing, dark second seeing, or 0.7. And they would almost never get observed. But then when people ask for NEOs, many times you're just interested in getting the position very accurately. Oh yeah, it's partially cloudy, or it's partially, the weather's not that great, but yeah, we can get that NEO for you. So I ended up doing a lot of NEO observations. And then after my PhD, somehow I was in the perfect position to go on to do a postdoc in NEOs in Hawaii. But I should add to that, so my actual PhD was also specialized in instrumentation. That started with, again, that I always liked tinkering with stuff. And I used to have a bunch of theorists, or I still do, theorist friends, and they were always way smarter than me. But then when it came to doing an experiment, or even just baking a pizza in the oven. They were just terrible. So that's where I found my niche that, okay, I can do this. And I really enjoyed doing that kind of things. And yeah, so I had both the instrumentation background and the kind of observational background that made me ideal for what they wanted me to do there in Hawaii.
Why are these objects important?
Okay. So every year we have asteroids that are actually hitting the Earth. So we know from records of craters that in the past there have been large impacts, such as the Chicxulub crater, which is, we think, is what was the crater that was caused by the meteorite that killed the asteroids.
That's the Yucatan Peninsula, right?
Yes, yeah. So I think that's the ultimate concern, that we're worried that could happen to us, and we want to first understand what is the likelihood of something like that happening. So first, to understand the population of NEOs. How many are there? What's their distribution? Are there just many smaller ones, or are there lots of more bigger ones? And then, so now we know that they're not super, super common. Like, we don't need to be worried about being wiped out by one of these next year. Then we look at, okay, but there are, of course, smaller ones. And there's been the Chelyabinsk event in 2013, which was about, I'm trying to guess, around 3 meters in size. I keep forgetting these numbers. But
there were a bunch of compelling dash cam images. And that was really fantastic to see.
Exactly. Even though that one was a smaller asteroid impact, and then mostly, of course, burnt up in the atmosphere, the shock waves actually were enough to break windows and cause damage. So it's something that people are beginning to realize more and more, that this could happen, and it's something we should look out for and understand. And then you have the very smaller objects, which are actually quite common. And people are surprised when I say, oh, there's on average about an impact per year of this 1 meter sized objects. And they're like, oh, really? I didn't know that. And most of them hit the ocean, so you're not going to know about them. But there's always a danger that if something hits in a populated, they're mostly going to burn up in the atmosphere. But people are concerned in areas with some geopolitical tensions that could be mistaken for and something more sinister. And so it's in our interest to warn people, oh, there's something coming.
How many of these are we talking about? So what's the frequency per year?
I'm going to cheat a little bit because I have a very nice slide, actually. I wish I could share it with you or send it to you, but it's a slide that we regularly talk about when we give talks. And it's a really nice graphic that Isa produced. And it's got...
I put it up online in the show notes. So if you send it to me after, I'll put it into the show notes.
Okay. Basically, the take-home message is that we have these 1 meter size objects that hit the Earth. There's on average every year. And most of them we don't know of. So 99.9% of them are still to be found. And that's something that we're working on. So there's still a lot of work for us to do. These are, of course, harmless, so they wouldn't cause any kind of damage. But then when you get to the Chelyabinsk size, the 10 meter, then there was Tunguska, which was another impact that happened. So that was more of a 30 meter sized object. These are less common. We're talking about around 1 million of these 10 meter sized objects. And these one of them would hit us approximately every 10 years. So Chelyabinsk size, roughly, objects.
So hold on. So we know that there's 1 million of these objects?
Okay, so we can get a bit more technical. It's not like we know. We know the ones that we know, which are about, let's say, the latest graphic says about 7,000. I think there's probably more than that. But from that population, from the distributions, we can infer that there are about 1 million that we still haven't found.
Okay.
But in total, that's the kind of number we think should be looking for.
So we got 1 million, so 7,000 known and potentially 1 million of the 30-meter NEOs. And then what's the next level?
Okay, before we move on, so of these objects, we also mostly haven't found most of them. So we haven't found 99.3% of them with the kind of, let's say, Chelyabinsk size. With the Tunguska size, we're around 80% that we haven't found. So we still need to do a lot of work. There's still...
So we got the Chelyabinsk, then we got the next size, and the larger the objects get, the more tricky things get, because the large objects are a problem. How big was the Chicxulub?
So we think it was something between 10 to 15 kilometers in size.
Wow.
So really huge.
Wow.
But the good news is there are not that many of those objects, and we think we found almost all of them.
Huh. So are those objects already inside the solar system, or do they come from somewhere else?
They're already inside the solar system.
Okay.
Yeah.
Okay.
Yeah.
Interesting.
So we think there are maybe 2% that we haven't found, and the ones we haven't found, if we haven't found them, it's probably because they have some kind of complicated orbit that would make it difficult for us to observe.
So I heard, and I do not know if it's just a rumor or a media thing, because it sounds great or it sounds dangerous, but some say it's a statistical certainty that Chicxulub will happen again at some point if you wait long enough.
If you wait long enough, yeah.
Is that so?
So the thing that we're not sure about is how often something like this would hit Earth. But yes, if you wait long enough, something's bound to hit you. Yes.
Huh. So and I think this is one of the reasons now that we're trying to build a planetary defense system.
Yeah. Yeah, and I guess it's partly so because you imagine orbits and you think, oh, these orbits are how they always were, how they always will be, but that's actually absolutely not true. And so, especially with these smaller objects, it's not just pure gravity that's acting on them. You have things like solar radiation pressure. So actually the light from the sun, the photons actually hitting it, are actually modifying its orbit slightly. And then you have Yarkovsky effect, which is another effect. But so they're not static. They're not, okay, place something in this orbit. It's always going to be in this orbit. It's not hitting the Earth now. It's never going to hit the Earth. And then you might have interactions between the different objects. And it's not something that, is not deterministic in that sense.
How does the surveillance system work?
In a way, it's very similar to weather forecasting, except we're doing asteroid forecasting. But there are two aspects: the observations, what you measure, and then the models and the numerical calculations, which give predictions. First of all, I can talk through the whole process of planetary defense. First of all, I guess it would start with the observations. There are, at the moment, several large surveys that are surveying the sky every night. These are just going to get more and more frequent as more countries, more organizations realize that this is an important thing. And they survey the sky every night. Typically, how we do it is we take sets of images. So let's say a pair of images, and then 20 minutes later, another pair. Then you could go back to the same field after 4 nights or however long. And then you compare the difference between the images and see if anything has moved. And then you see if that motion continues and if you can fit an orbit to it. So the typical kinds of orbits that can be fit, the standard one is a heliocentric orbit. So if you find something that's moving and you can fit it to a heliocentric orbit, you know it's something that's in the solar system.
How does that fitting work? Because usually it's a straight line in your image, right? Would that, I don't know, could any human do that, or is that only possible because you throw a bunch of math at it and computers will tell you?
It's not a straight line. It's definitely on a celestial sphere.
Mm-hmm.
It might appear as a straight line because the sky is very large and you're just looking at a very small part of the sky. There are, of course, projections involved. So you are projecting a sphere onto a flat CCD image. And there's math involved.
Of course.
So what we just do is we provide positions, and then these positions then get linked by the orbital computational software to various orbital options. And it's not a one orbit. It's based on the uncertainty that you have. It's a range of possible orbits. So the more observations you have, the more precisely you can define the orbit. If you only have a few observations, you could fit a lot of different kinds of orbits. So you could even fit some that are heliocentric, some that are geocentric. Geocentric orbits are interesting because usually that means that the thing that we're observing is actually something that has been launched from Earth. A satellite, a rocket, a booster. So then we know, okay, we don't need to worry about that particular thing. But it has happened that we observe these things. And if you don't know that initially what they are, because they're made of many times like metal, reflective material, they appear like a much larger asteroid. And then once, okay, it's just a booster, then you can stop worrying about it.
Will Apophis be an issue in 2029?
In terms of, should we be concerned? No. It's going to be a spectacle. It's going to be a great opportunity to highlight the importance of what we do and planetary defense.
Maybe we should explain what Apophis is. So it's my fault. So let's go back a little. What is Apophis again?
Not the best one to tell big stories, but there are big stories about Apophis. And basically, it was the riskiest object for a very long time until observations removed it some years ago. And for a long time, people were worried and people thought that it has a high chance of hitting the Earth. But the most recent observations have conclusively ruled out the chance that Apophis is going to hit the Earth.
It's a couple of 100 meters big, right?
Yeah, so I think it's like something like 325 meters.
Okay, so that's considerable.
It's considerable, yes. It's going to come, I think, within the geostationary orbit, I think. So it's super, super close.
So what does that mean? Because I think it's got a period around Earth, so it's coming back.
It's coming back, yes.
Does Earth's gravity pull on Apophis, so next time it comes around, it's even closer? Or is it not that easy?
So I think there have been calculations done. I think it's not a trivial calculation to make. And some people were legitimately concerned that even if it doesn't hit the Earth this time, it might come back around and hit us the next time it comes. I think, as far as I'm aware, that's been also conclusively ruled out at this point in time. But now, who knows, the third or fourth time, there might be complicated other interactions. But we know the orbit of Apophis very well. And at the moment, I wouldn't be worried about it.
Thank you for that. We will live.
We will live.
I read you have your own asteroid. Is that true?
I do. Yeah, I do. That was a very nice surprise for me, but it's a little treat, let's say, in the community that after working in the field for a certain number of years, you get nominated to have your own asteroid. Yes.
Wow. So how does that work? I figured you need to discover your own asteroid and then you can name it, or how was that in your case?
Yes. Yeah, so I think there's some rule that you cannot name an asteroid after yourself. So if you discover an asteroid, you can name it after someone else. So when the committee decided that they have every few years, they have a big meeting where they announce they would award these asteroids to. It's typically asteroids that have already been discovered many years ago by a survey somewhere. So it's typically these are all discovered by surveys, and then they hold on to them.
Unnamed orphans.
Yeah. I have a colleague and a friend who he's discovered a couple of asteroids himself, and he's hanging on to them until he has enough for all his friends and family so he can name them all after each one of them and not offend anyone.
So then you got your asteroid. And so how does that naming work? Is there a reason why you can't name it after yourself?
I think it's just the rules of the International Astronomical Union.
Maybe
they decided it to be like that.
You shouldn't deify yourself by having a celestial object named after you, maybe.
You can name comets. So comets are typically named after their discoverer.
Uh-huh.
Many times it's just the name of the survey, which is less fun, but I have no idea why it's that way.
Maybe it's because of the destructive power behind it. So if Dora Föhring was responsible for the destruction of the biosphere?
That's true, yes. So that's actually true. I think the asteroids were named or the asteroids that are named after us, they're all main belt asteroids. So they don't pose any risk to the Earth. I think it's true that NEOs, don't think you can name them after yourself.
Dora, tell me about the DART mission. You were involved in that mission, and DART is part of the planetary defense mission, and it's what the first phase of trying to deflect the double asteroid system, Dimorphos, Didymos. So what was your involvement in all of this?
So it all started back when I was in Hawaii, and the DART team was getting together, and there was this idea to test this asteroid deflection mission. The idea was to see whether this is the first time in humanity that we can actually do something about a potential impacting asteroid. Of course, Didymos and Dimorphos were not impacting asteroids. They were just sitting there. But the theory behind it was that because it's a binary, you can measure the period of the system very easily and see if you have made any change. And if you change the velocity of the system, then you change the period as well. So that was the theory behind it, to hit the small asteroid and see if you can produce this change. And to start off with, the system needed to be studied in.
So would you actually take video, or are we talking about photos that people are taking?
That's a very good question. That's a very, very good question. So two things. One is you touched upon, can you actually see it? And so the answer is, so the brightness, I think it was around, it's like 17 magnitude. So it's something that you could observe. But the main thing was that when DART hit the asteroid, there was a predicted very large spike in the brightness due to all the dust and material that was being ejected. And actually, that was a very challenging question that modelers thought a lot about. It was how bright this thing was actually going to get, because they didn't know, and they were revising their models week after week almost. And so it was also challenging for us because we were trying to pass on the information to the observers. Like, it's not something you could program that easily in like I was mentioning with the Gemini observations, like take 10-second exposures. You had to be a little bit like, oh, well, start with taking 10 seconds. If it starts saturating your image, then maybe you want to start shorter exposures. And not exactly, but you had to be a little bit more ready to adapt your strategy and how things evolved. And that was really part of the exciting thing.
Are we ready to deflect asteroids on a regular basis if we wanted? So are we ready for the Iron Dome, the asteroid Iron Dome? Technically?
I don't think it's going to be an Iron Dome. I think there are obviously large costs involved in building such a mission. It's not like you pay your $20 or whatever and you get one of these. It's expensive. It's complicated to build such a mission. And I think the DART mission was many years in the planning and involved a large number of scientists. Now, if we would have to be launching this year after year, that would be,
of course,
quite a different thing. It would be quite challenging and taxing, I think, on all of us.
How far are you on your journey towards finding what you're looking for out there in the universe?
Wow. My journey of find, it's a very deep question. I think there's always more to discover. There's, of course, the journey outward. There's always the journey inward. I think, gosh, it's like metaphysical almost what we're touching upon. I think that's right, because initially the questions I was curious about were the questions that everyone is curious about. What else is there? Is there life outside of the or outside of the Earth, somewhere else? Is what happens after death? What happens before birth? And yeah, there are questions that physics or science cannot answer. So then it's a kind of journey inward. In terms of finding what I would be really excited to find, and I think everyone would be really excited to find alien life, I think. But again, it's a kind of, it's really deep. Like, why do we really want to find alien life? In a way, it's to have a way to see ourselves better, I think. Look at ours.
We just had Pascal Lee on the show from SETI and NASA Ames. And we were talking, as you will imagine, quite a bit about aliens out there. And he said the likelihood that we find extraterrestrial life in this century is quite high, but it's not going to be complex. It's not going to be intelligent. This is a completely different cup of tea. So we're not going to find an alien civilization anytime soon. This is what he thinks, but he is pretty sure about us finding life in, I'm hesitant to say primitive, but what is primitive? Who are we to say what is primitive? But in different forms, maybe, I don't know, cells or whatnot. So what's your take on that?
I certainly think that's a good way to start, I think.
Do you have a favorite place where we should look? If you were given the reins of defining the next mission to search for extraterrestrial life, where would you go?
I mean, I think certainly we should start with the solar system, start with the things that are close to us. Our own neighborhood. Start with Mars, then, so moons of Jupiter, I would say, have quite likely that there's something going on. Venus, I'm not sure. Could be not. That's where I would start.
On X, you're describing yourself as an adventurer. So what's going on here?
I think I wrote that some time ago. I think it used to say a dreamer, but I think I thought, that I should change that now to adventurer. The adventures. I think it just started happening to me. I guess my first adventure, let's say, as a student, I was doing it on La Palma. So it's a small island and there's not that much to do there. You get a bit bored after a while. You start going a bit crazy. And so then after some time, I noticed that the people who were like really happy there, they were all scuba diving.
Wow.
I started doing scuba diving on the weekends. And then it just kept happening. So then after my PhD, I ended up going to Hawaii, continued the scuba diving plus some hiking. There you can start getting into a bit more challenging hikes. And I think I really caught the kind of outdoor spirit there. There are just so many amazing things that you can do there. You can go kayaking, hiking, sailing. And now I'm in Italy and I thought, okay, it's time to calm down. But actually, there are very cool things you can do in Italy as well. The scuba diving is continuing, but here in Europe, it's a bit cold. I think the next step will be probably to get some kind of dry suit certification. And yeah, I really enjoy traveling to challenging places, let's say, also around Europe. And yeah, I find it helps offset sitting at the office and the desk all
Absolutely.
the time.
Fantastic. So you got La Palma covered, you got Hawaii covered, you got now Frascati in Italy covered.
Yeah.
Are they comparable?
No. I could say Hawaii is like La Palma in a way, but Italy's completely different. They're all beautiful places. I think that's what they have in common.
Why on earth would anyone leave Hawaii?
I had the Romans ask me the same question. They're like, Dora, you've lived in all these fantastic places in Hawaii. Why on earth did you come to Rome? And they're like, but you live in Frascati, so I guess that's okay. I was there on a temporary research position, and here I have a permanent job. That's the short answer. The longer answer is that it's a fantastic place, but then at the same time, it's very remote. Here I'm a lot more connected, both to my friends, to my family, to other things going on. It's much easier to travel, to do things. It gets very same old after a while. But I would, of course, love to go back.
So you're an astronomer, and astronomy brought you to all these places, right?
Yes. Yeah.
So how did you get into all this in the first place? Was astronomy always your desire?
Yeah, I think it was. I think even as a child, I was really fascinated by just the nature around us, whether studying insects or even just taking pens apart, putting them back together. And then I got really fascinated by astronomy just from books that I encountered. And then later on, by watching science fiction shows like Star Trek. Do you remember Sliders back in the day? It was a show about a physics student, like graduate student, I think, or undergraduate even, who was like tinkering with this magical scientific remote control that could open portals into other, and that really inspired me. I was like, man, you can do that with physics. That must be so cool. And yeah, I had a little book on like astronomy and constellations, and I used to go into my garden and look up at the stars. But yeah, I think that was really the kind of first fascination through being inspired by science fiction, and then later by the actual science, and also scientists themselves. They're like reading books, such as books by Richard Feynman, and being like, oh wow, they're really cool people. I want to learn more. I want to be like them or do cool things like they're doing.
But anyways, if the call came, would you be ready to go somewhere, to go to a celestial body with Starship?
It's funny because I was watching your podcast with Andy Rifkin, and you asked him the same question or something similar. I think it would depend on what the mission actually involved. I think if it was like a one-way ticket to Mars, I would say no, simply because I think I can, or I hope I can, accomplish more by being here. But I think if it was like a there and back trip that lasts maybe a year or so, I'd do it for sure. Then I guess there's also the risk factor involved. Would I be the first person to do it on a slightly untested rocket? Maybe there are far more qualified people for that than I am. But if it was a regular thing that people would do and it was fairly tried and tested. Yeah, why not? I think there are crazy people. There are people doing crazy things all the time. Just, I guess the question would be like, what are you trying to achieve with that? Like, is it to prove something to yourself? Is it to see something different? Is it to experience something different? You know, there are very rich people trying to climb Everest just to prove that they can do it, or go to the bottom of the ocean, like we've seen.
Well, this is one of our qualities as humans, that we're always trying to do one more step.
Yeah.
As you have been listening to Andy Rifkin, now you know what my next question will be.
I didn't listen to the whole thing. I briefly listened.
Yeah. You will now know what the next question is, because this is literally a question I keep asking each of my guests. And now for that journey to Mars, because it's going to be a long and boring journey, what's the one piece of music you would want to bring with you to keep you entertained, to keep you happy, or whatever? Because we have that playlist on Spotify. It's the playlist for the aspiring space traveler. And we keep adding to it based on the replies and the choices from our guests.
God, that's fantastic. I love it. It would be something from Iron Maiden, and it would be one of their longer songs, just to make it last longer.
Alexander the Great.
Yeah, why not?
No, you pick one.
What were their most recent song? I think it's called Hell on Earth, I think. And it's actually like very uplifting.
Must be a jolly tune.
No, it's very uplifting. It's basically about like how he wants to improve things, and now there's a hell on earth, but he wants to escape from it and make things better, and how he would make things better. Yeah.
Great. Great. Fantastic. So be it. I'll put it on the playlist.
Fantastic.
Speaking of Iron Maiden, my all-time favorite album is Somewhere in Time. I think
that's a good one.
That would be a nice fit for our space conversation. A nice soundtrack. But I'm definitely going to listen to that one you just suggested.
I think that's the name of it. Yeah. You should double check.
Yeah, sure.
He's definitely singing about Hell on Earth. It is called Hell on Earth by Iron Maiden, yes.
Fantastic. Good. Last question.
11 minutes.
Last question, Dora. This is the Space Cafe podcast, a coffee place, so to say, where we can hang out and have more or less meaningful discussions. Now and then in coffee places, you have an espresso to energize yourself when you're worn out and tired.
Oh, nice.
What's the espresso for the mind you would like to share now? Who you'd like to serve now to me, to the audiences? And you can pick whatever kind of topic you want to pick, where you feel like this could be something energizing, something inspiring.
I think I would say, like, you should be a yes person. And if you're not sure about something, just say yes. Unless it's something silly, your flatmate wants to wash their dirty laundry just say yes to challenges and be open to new discoveries and to putting yourself out of your comfort zone. I mean, when I first got told, I have this chance to go to Hawaii, I was like, I think my mother was like, is this a scam? And I think many people would have said no, and because of whatever, too complicated, it's too scary, it's too different, too difficult. And coming here also. So I would say definitely say yes.
Love it. Dora, thank you so much for your time.
Okay, yeah. Thank you as well. I hope that was okay.
And that's a wrap on our cosmic adventure with Dr. Dora Föhring. What a journey we've been on today, from tracking elusive space rocks to making history by actually nudging an asteroid off course. Talk about a job that's truly out of this world. I don't know about you, but I'm feeling a mix of awe and relief. Awe at the incredible work of Dr. Föhring and her team are doing, and relief that we've got these brilliant minds watching our cosmic backs. It's reassuring to know that while Chicxulub 2 might be lurking out there. We're not sitting ducks anymore. Remember when we used to think asteroid defense was just sci-fi movie stuff? Well, Dora Föhring and her colleagues at ESA are turning that fiction into fact, one space pebble at a time. They are writing a new chapter in human history, and we got a front row seat to hear about it. I hope this episode has sparked your curiosity about our place in the cosmos and maybe even inspired some of you to look up at the night sky with a new perspective. Who knows? Maybe we've got some future planetary defenders listening right now. If you enjoyed our chat with Dora Föhring, don't keep it a secret. Share this episode with your space-loving friends or anyone who needs a reminder that there are some seriously cool jobs out there. And hey, while you're at it, why not leave us a review? It helps other cosmic explorers find our little corner of the podcast universe. Until next time, keep your eyes on the skies, but rest easy, knowing that Dora Föhring and her team are on Asteroid Watch. This is Marcus signing off from the Space Cafe podcast. Stay curious, stay cosmic, and we'll catch you on the next orbit. Bye-bye.